A very good morning to you all students. Students, I welcome you all to the chemistry online class. Today we are going to discuss about the topic concentration of an ore. The last class we have studied about terminology in metallurgy. I hope that you all studied the terminologies. So, what are the terminologies we have? Mineral, ore, mining, gang or matrix, flux, slag, smelting. Am I right? Okay. Then we studied the principles of metallurgy, isn't it? What are the principles or what are the steps that involved in the metallurgy? Do you remember the main three steps that comes under metallurgy? The first one is the concentration of the ore. Next one, production of the metal. Third one, refining of the metal. In that, today we are going to see the first method or first step. What is that? Concentration of an ore. So, after the mining process, what is mining? The process of extracting the ore from earth crust. After extracting the ore from earth crust, next we will do pulverization, that is crushing of the ore into small pieces. After that we have to separate the impurities from the crushed ore. That is called as concentration of ore. That is the removal of impurities from the ore. Since it is taken from the earth crust, earthy impurities are associated with what? Our ore. Isn't it? So we have to remove all the impurities. What is the other name for impurities? Do you remember? What is the terminology used for impurities? Yes, it's a gang, or we will call it as matrix. So the concentration of ore is the process of removal of gang or matrix from the ore. We have so many methods to remove the earthy impurities or gang from the ore. And the methods are chosen based on the properties of ore. The proper methods are chosen. In our syllabus, we are going to see about the 4 important methods that is used for the concentration of ore. In that, first one is hydraulic method. Second one, magnetic separation method. Third, fourth, flotation. And finally, chemical method or leaching. So these are the 4 methods commonly used for the removal of gang or matrix from the ore. Have you understood? Now we can see the first method, that is hydraulic washing, or we can call it as gravity separation. What is hydraulic washing or gravity separation? See, the main principle behind this hydraulic method or gravity separation is difference in the density of ore and gang. Based on that, we will separate the ore and gang. So the main principle behind this method is density, difference in density between the ore and the associated impurities, that is gang. See, mainly this method is used for oxide ores. The removal of impurities from oxide ores, this technology is used. Have you understood? The principle is what? Difference in the density between the ore and the gang. And what are the types of ores that can be concentrated by this method means mainly oxide ores. Example, bauxite, hematite, cuprite. Okay, bauxite, the ore of aluminium, cuprite, the ore of copper, hematite, the ore of irons are commonly concentrated by this hydraulic washing. Have we clear? Okay. Now we can see how this works, how this method See, the ore is first crushed, isn't it? After taking from earth crust, the ore is crushed into small pieces. After that, it is subjected to hydraulic washing. The ore is poured over a sloping table. In the diagram, you can see there is a table with grooves, isn't it? With up and downs. Have you seen? Yes. From top, the water is allowed to flow over it at a high speed. That is, the current of water, the stream of water is allowed to pass through the crushed ore which is present on the sloping table with grooves. So what happened? If our ore is a heavier particles, okay, you have to keep it in mind. This technique is only followed if our ore is heavier than the gangue, because the principle is based on what? Density between ore and gangue. So if this method is only applicable if our ore is heavier than the gangue, if it has high density than the gangue. So the crushed ore is placed on the sloping table with grooves, and a stream of water with a high current, that is with a high speed, is allowed to flow over the crushed ore which is on the table. So what happens when the water comes with a high force? It takes away or it removes the lighter particles, that is the gangue particles that attach to our ore, and it is washed down by the water, whereas the denser particle that our ore will get settle on the grooves that are present on the table. Likewise, this method will be done. Have you understood, students? Hydraulic washing or gravity separation principle is density between, difference in density between ore and gangue. The working, how it works? It kept on the sloping table with grooves. From the top, the water is passed. The stream of water is passed with a high speed over the ore, which removes all the lighter particles that are attached to the ore, and it is washed away, and our denser what? Ore will be present on the grooves of the table, which is separated. The next method is magnetic separation method. You all know magnetism, isn't it? So what is the principle behind this means? See, out of our ore and gangue, one should possess magnetic property. Other should not possess this property. Then only this method is applicable. Have you understood? In hydraulic method, what? Our ore must have heavy density. Then only it will settle down on the grooves. Here, among the two, that is gangue and ore, one should possess the magnetic properties. So it is based on the magnetic properties of the ore from the gangue. And mostly the ore which is separated by this technique is tin stone, the ore of tin, and also you can separate the oxides of iron. What are the oxides of iron? Do you know? Yes. It is also used to separate the iron from magnetite, hematite and iron pyrite. Okay. So it is also used for the separation of tin stone, that is the ore of tin, and also magnetite, the ore of iron, are done by this technique. Here in the diagram you can see, here it consists of two conveyor belt which rotates around two metal wheels. In that we have to load the finely grounded ore. So what happened? This finely grounded ore rotates around the two metal wheels, in which one is magnetic. So the ore which has the magnetic particles are attracted to the magnetic wheel, whereas the gangue or the impurities, which are non-magnetic particles, fall away from the wheel. That this conveyor belt separates our ore and the that is our ore and the gangue particles. Have you understood? Otherwise, you can say it separates magnetic particles from non-magnetic particles. Once again, magnetic separation method, the main basic among the ore and gangue, one should be either the ore or the gangue should be magnetic. Then only this method will be employed. Commonly it is used tinstone and magnetite are commonly concentrated by this technique. It consists of two conveyor belt rotating between two wheels. Among the two wheels, one is what? Magnet. The crushed ore is loaded over the conveyor belt. When they are rotating, what happened? Magnetic particles will attract towards the magnetic field. The non-magnetic particles fall away from the non-magnetic wheel, so that we can separate both ore and gangue particles. Have you understood? So that is magnetic separation method. The next one is froth flotation technique. What is froth? You know, isn't it? What is froth? Froth means what? You know, foam, isn't it? While washing the clothes using detergent, you can see the froth formation there, isn't it? With the bubbles, it forms like a foam, isn't it? So that is the froth. And this froth flotation technique is mainly employed for the separation of sulfite ores. For the separation of sulfite ores. The sulfite ores, at also it should be a lighter ore. It should not be a heavier ore. For heavier ores, this method is not applicable. Only for the lighter ores, it is mainly sulfite ores. We have different types of ores. In the last class we studied, isn't it? Oxide ores, carbonate ores, halide ores, sulfite ores. Among this technique is mainly employed for the separation of sulfite ores. Can you say some example for sulfite ores? Yes, galena, it is the ore of lead, iron pyrite, ore of iron, zinc blende, the ore of zinc. Okay, so some of the among these also, only these sulfide ores, only the lighter ores are used. So lighter ores means it may zinc blende and galena. We will mainly apply the froth flotation technique because the ores are lighter. When comparing to iron pyrite, galena and zinc blende are lighter ores, and these two can be separated by what? Froth flotation. And here what is the principle behind this froth flotation means wettability of the ore with oil and the gangue particles with the water. Here mainly the principle behind is our ore, increasing the wettability of our ore with the oil and preventing its wettability with the water. Okay, here ore and gangue, these are the two main things, isn't it, in concentration of ore. We want to remove this ore, that is from ore we have to remove the gangue particles. So in this technique they will increase the wettability of ore with the oil and the gangue with the water. So in here in the diagram you can see what they will do means first they will crush the ore, that is pulverization, isn't it? Crushing of the ore into small pieces, and it is fed into a large tank that containing collectors. Collectors, collectors, collectors. What are the collectors? Collectors means nothing, that is which forms froth. That is either you can use pine oil or fatty acid and be also used for this process. Not only pine oil, students, fatty acids can be also used for this process. So the crushed ore is taken in the large tank. To this tank we will add some collectors, either what? Pine oil, or we will add what? Fatty acid, and also we will add water. Okay, so this large tank contain our ore with gangue or matrix and collectors, that is pine oil or fatty acid, plus we will add what? Water to this. Okay, Then we have to stir the content well. That is stirring. That is called as agitation. Agitation means with the help of the air, we have to agitate the solution. Okay. The help of a high current, the compressed air. That is what? Agitated with a current of compressed air means what? Means at a high force, the pressure is put inside the tank and it causes agitation. Okay. Washing machine you can see, isn't it? It will agitate, isn't it? The cloth inside the washing machine, isn't it? So like that, inside the tank, our ore, our gang, water, oil, everything were mixed well by using compressed air. That is called as agitation, mixing, equally mixing. Okay. After that, what happened while agitating this mixture? Our ore is wetted by the oil. Our ore is wetted by the oil. Since it's a lighter particles, it is wetted by the oil and gets separated from the gang in the form of froth. So, while agitating this solution inside the tank, there will be due to the addition of oil, pine oil, or due to the addition of fatty acids, there will be a forming froth. For the formation of froth, only we are agitating. Since our ore is lighter particles, along with the froth, it comes to the top of the tank as a froth or as a foam. And this heavier gang particles, that is separated at the bottom of the tank. Since the ore is lighter, it comes with what? The froth, whereas the impurities left behind on the bottom of the tank. Have you understood? So that from the top, the froth is skimmed off, okay, or removed off, and the ore is separated. And the ore is separated, and the impurities are left behind that bottom of the tank. Have you understood, students? So here mainly the difference in the wettability of ore with oil and the gang with the water. So what are the content we are adding to the tank? The tank contains our desired ore with impurity, plus we are adding collectors like fine oil or what? Fatty acids plus water. When for equally mixing and formation of froth, we are agitating by using the compressed air. While agitating, our lighter ores comes to the comes to the top of the tank as a foam or a froth. That bubbles carry the sulfide ore particles because it's a lighter one. Whereas the gang will settle at the bottom of the tank. So this is commonly used for the lighter ores such as sulfide ores, mainly zinc blend. That is what? For zinc blend, that is certain as zinc blend and galena. Have you clear? The last method is chemical method or leaching. The before three, what we studied, hydraulic, magnetic and froth, we can call that three as physical methods. But here you can call leaching as chemical method. Different types of leaching is there. Acid leaching, basic leaching using ammonium cyanide. Different types of leachings are there. Okay. Based on the ore, we will select the proper leaching method. So here what they will do means, if the ore is treated, here the main principle is difference in the solubility of ore with the suitable reagent. Solubility of ore with the suitable reagent. So here after crushing, the ore is treated with suitable reagent like strong ammonium hydroxide. Ammonium hydroxide, no, sodium hydroxide. We can use, normally we will use sodium hydroxide for leaching purpose. Okay, a strong solution of sodium hydroxide is used here as chemical. So the ore is treated with suitable reagent like sodium hydroxide, in which the ore is soluble, whereas our impurities will not get dissolved in the sodium hydroxide. Have you clear? The ore will get soluble with the sodium hydroxide, where the impurities will not get dissolved or will not get what? Soluble with our sodium hydroxide. So they will get settled down as impurities and it is removed off by filtration process. Okay, the ore, when you dissolve in sodium hydroxide, it forms a precipitate. It forms a precipitate, we can call it as a precipitate, which is later on, this precipitate ore is later on, it will be converted into what? The desicced ore. So the first one, the ore is treated with suitable reagent like sodium hydroxide. This sodium hydroxide makes the ore to soluble in it, but the impurities will not get soluble. The impurities will be settled down at the bottom and it is removed by the method of filtration. The solution of ore, that is filtrate, the solution of ore, that is which is soluble in sodium hydroxide, forms a precipitate, okay, and this precipitate later on heating and diluting it with water, we will get the consider amount of ore. For example, bauxite formula Al2O3 2H2. So this is the ore which contain impurities also. So this bauxite is added with the sodium hydroxide NaOH. Okay, it is added with the sodium hydroxide, so that it forms a soluble substance called as sodium meta-aluminate. It forms what? Sodium meta-aluminate. Okay, then this sodium meta-aluminate is treated with or diluted it with water. It forms a precipitate called as aluminum hydroxide. It forms a precipitate called as aluminum hydroxide. Again, this precipitate is filtered, washed and heated to get our pure ore, that is alumina. Pure ore, what is that? Alumina. Have you understood, students? Once again I am see, the ore is treated with a leaching agent. Here we are using the leaching agent is strong sodium hydroxide, so that they form a substance called as sodium meta-aluminate. On diluting this, that is a soluble substance with the sodium hydroxide, the ore is dissolved with the sodium hydroxide and forming a complex structure called as sodium meta-aluminate. Then this sodium meta-aluminate is, we are diluting it with water so that it forms aluminum hydroxide. Then this aluminum hydroxide is in the form of precipitate. Aluminum hydroxide will be formed in the form of precipitate. Then we should take the precipitate, it is filtered, it is washed, it is dried and it is heated nearly to 1000 degrees Celsius, so that we will get pure ore, that is alumina. Pure ore, that is alumina, by removing all the impurities. So this method is called as what? Leaching. This method is called as what? Leaching. Have you understood? Here, one important 5-mark question, and also it can be asked for 7-mark question. See, describe the the steps or describe the types of separation of ore. Describe the different types of separation of ore, or you can learn all this. For this question, you have to learn for 7-mark or for 4-mark it can be asked. For example, they will ask, explain the hydraulic washing method used for the concentration of ore, or explain the magnetic separation method. Likewise, the question will be there. Otherwise, they will ask, what is the method used for the concentration of lighter ores? So, lighter ores means sulfide ore. So, what technique you have to write? Froth flotation. Have you understood? So, if the ore has the magnetic property, what is the method used? Magnetic separation. For oxide ores, mainly what method we will use? Hydraulic method. So, this question can be asked for 7-mark question or 4-mark question. So, students, you have to learn all the that is page number 113. All the 4 methods briefly for the 7-mark question, or individually it can be asked for 4-mark question. There is no question related to book bag from this side. Okay, ma? So it's a book inside question and you have to learn. It's very important. Froth flotation technique is very important. Leaching method is very important. All the 4 technique is very important. So learn it for 7-mark question, and it's very easy also. Okay. So keep on learning, students. So the next class we will study the properties of metals. Thank you.